let's. They need to be able to control them. All right. Are we all moved into place? There's still some more seats down here. There's some in the middle here, please. There's one right down up front. You can get a ringside seat. There's some over here. So please follow the people that are raising their hands. You can come around both sides, and please, if you would, not sit in the aisles, since I want to sit in the aisle. So, okay. No. All right. We are ready. I don't think this person needs any introduction. And since we all want to hear and get on with questions and answers and the presentation of products, and say what? Evangelize what? Yeah. Well, I could give a pitch, but to show you how selfless I am, I'm not going to tonight, because I'm going to bring on our honored guest, Bill Gates, the boss. Thank you. You bet. Well, it's great to finally be here, I guess. Actually, I was here about 3.5 years ago. About 3.5 years ago. What I want to talk about tonight is what Microsoft is doing and what I see happening in the PC industry. But I'm going to leave most of my time for you to ask friendly questions. Well, it was about 15 years ago when I was trying to go to school back at Harvard when the first PC came out. And this, of course, was the kit computer that appeared on the cover of Popular Electronics. It wasn't a very powerful machine. It was only sold as a kit. And in fact, the company who made them had only assembled 2 of them. They'd sold about 5,000. When we got there, we noticed a lot of people didn't realize they had to buy memory when they got the machine. So we always wondered what the people who got the machines without a single byte of memory did with them. Most people got 1K, and the initial software library was flashing things up in the lights because they hadn't done any peripherals yet. But it was with this machine that I spent a summer going around demonstrating and helping start up some of the oldest computer groups in the nation, and that was 1976. Microsoft got started with kind of a strange idea, was that instead of doing hardware, we would only do software. And the reason that was strange was that it wasn't clear who we'd sell our software to. But I had an idea that it would take us long enough to write good software that somebody would show up. Our first 13 customers were companies that you probably wouldn't remember. They all went bankrupt within a couple years of licensing our software. There were companies like Spear, MIT, IMSI. Some lasted longer, Processor Tech, Southwest Technical Products. But it was all 8-bit processors, not very powerful machines. And it was only in the late 70s that we started to see the machines being used for productive functions. We went through a lot of fun innovations. The floppy disk was a big thing, memory beyond 64K. The first portable computers, LCD machine, was the machine I worked on in 1980. And one of the wilder ideas was this idea of getting multiple manufacturers to build compatible machines. Some people think that's a good idea, some people don't. But it was something we promoted very heavily because in 1980 there were 42 types of personal computers. So no type had sold on average more than about 40,000 machines. And it meant that it was very difficult to write software. There were a class of machines called CPM80 machines, but even those had different types of disks. And in fact, the most popular CPM80 machine was a little soft card that Microsoft built that plugged into the Apple II. But we went around and convinced people that they should all make compatible machines. And today, that's led to there being literally only two desktop standards, the machines that Apple builds and the machines that run MS-DOS. And that's a great thing for software developers. Now we only have two targets to go after. It was in 1981 when I first started talking with Steve Jobs about the Mac. I hadn't worked with Jobs much. I'd worked with Wozniak and Wigington and a number of people doing the AppleSoft BASIC that was part of the Apple II. But Steve came down and said he was interested in graphics. And of course, we had hired some of the original founders of Xerox Palo Alto Research Center, including Charles Simoni, who wrote the first graphical word processor. And so we really believed that that kind of interface, what they'd had on the Alto in their lab, was what would take over. And it was pretty exciting to see what Steve was doing with the Mac. Of course, when he came and talked to us, he was telling us that he was going to ship it in about a year. Took him a little bit longer than that, but once again, that gave us plenty of time to write the software. We saw this as a pretty critical advance in terms of making the computer more usable. We had said in 1975 that we actually thought there'd be a computer on every desk and in every home. 15 years later, we're a quarter of the way there, or a fifth of the way there. Not even halfway, but I think in terms of time, if you look out 15 or 20 years and imagine how the PC will change, it's not such a wild idea. At least it's not as funny as it was 15 years ago when we said it. And that, well, I never finished my classes. I have no degrees of any kind from Harvard University. I went through my junior year of high school, and then I was offered a job by a big company, TRW, doing computer programming, and that was so much fun that I kept doing that. But then all those guys wanted me to go off and go to Harvard, so I spent a couple of years there. But it was fun, but not as much fun as being involved in getting going with the industry. In fact, the thing that Paul Allen, who was my co-founder, and I were most worried about is that the whole thing was going to happen without us. When we saw the microprocessor, we thought this is an incredible technology, and we wanted to be there in the very beginning. So, although I'm officially on leave of absence, it's been about 16 years now, and I think they consider me an alum in some respects. Well, so here's the first Mac. Those of you who worked with this machine will remember it was a very tough machine to write software for. It actually only increased the amount of memory available for programming by about 50% over the 64K machine. Because although it was a 128K machine, 22K of the memory was actually the video buffer, and about 15K was set aside for the system heap and system variables. And so what we wanted to do is take character mode software like Multiplan, put it into the modeless graphical format, and do it with very, very little memory. It also had one of the slower floppy disks of all time, and so it wasn't like you could page your data in and out as the way to get around this. And there were basically, when the machine shipped, there were two sets of software shipping. There was the work that Apple did, and that was paint and write, and that's people like Atkinson and Wigington who got down and wrote very, very tight machine code. And there was the software that we shipped because we'd written some very special tools that allowed us to compact our code and get them into the machine. And it's interesting, how little software actually got written for the 128K Mac. The 512K Mac was a godsend when it came along because it allowed people to do a lot more things. This is a picture of the major software companies that signed up to do Mac software. Steve went around and he did a great job of evangelization. He had us signed up, but he spent a lot of his time getting people excited. And of course, Mitch Kapoor, who's in the center here, ran Lotus at the time, and he signed up to do some great things. And then Fred Gibbons, who's from Software Publishing, also signed up. And this photo is actually kind of a famous photo from posters that were sent all over the place. It was taken when we went to the Apple sales meeting, where they first showed the Apple sales meeting, the Macintosh. And I have to say that was one of the funnest events I ever went to, because they hadn't seen it before, and they were amazed at what they were going to get to sell. It is kind of a proof that when a new machine comes along, it's typically new software companies that really understand what it takes and write the great software. All the companies that have been successful at doing software on the Macintosh really were new companies, with the exception of Microsoft. By 1985, we had the following products out. And each of these, it was pretty tough. They all had to fit into that 128K machine. They all did super well. But since we've gone on, we've taken, of course, multi-plan and chart and superseded those with Excel. We've done a lot with the other products. I'll just touch briefly on each of the major products before I go into the ways that PCs are changing. I don't have a specific slide on Flight Simulator, but you'll be pleased to know we will have a new version this year that will run in color on all Macintosh machines. So look forward to that. Even SEs. Now, the one product I want to give you a quick demo of tonight is Excel 3. That's a product that just shipped a few weeks ago, and it's the first major application to come out and fully exploit Apple's System 7. In fact, the trickiest thing about Excel 3 has been timing our release along with Apple's, making sure they're getting the disks up to us and do the testing. And we're just hoping they don't change anything at the last minute to cause a problem. So far, it looks good for that, because we have been working very, very closely with them. Another big thing for us this year is going to be a major update of our Word product. Some of the things you're starting to see in word processors are advanced macro languages, drawing capability built in, a lot of clever things with speed, and somewhat of a crossover where word processors are getting a lot of the features you'd think of in a desktop publishing package, and likewise the desktop publishing packages are now including in a lot of word processing features. It's not clear where the dividing line between these two categories are, but one of the major things you'll see from us are a lot of features that take Word a lot further than it's gone before. We're also working on Works and going to do a major new version. The exciting thing about this is that with Apple doing such a good job bringing out low-priced machines, actually this product has become even more significant in our product line than it was, say, a year ago. A lot of people buying, particularly the LC, have gone ahead and bought Works. And it's already an integrated package. There's a lot of things we're doing to make it even more integrated and beef up each of the individual areas. Another major release we'll have this year will be PowerPoint working with System 7. This is a case where we'll enhance the drawing capabilities very dramatically. We'll bring in the outline concept into this product. We are starting to see a number of features that started in one category, say outlining, which was either a category of its own or just in word processing. I'll show you that tonight in Excel, and of course in PowerPoint you'll also see the outlining feature. We think that things like outlining and styles being the idea of taking a set of attributes you specify and giving it a name, so that not only can you apply that easily to other places in your information, but also that if you want to change the way things appear, you don't have to go back and touch all those places. You simply redefine the style, and you have this level of indirection that makes it happen automatically. That'll be a critical feature in every one of our major productivity applications. Also, as you'll see with Excel, there's this idea of a toolbar that takes, we bring people into a usability lab, and we see what are the operations that they do 90% of the time. And we're able to put those in a point-and-click form right under the menu bar and make it so you don't have to do nearly as many operations. Over time, that'll become a customizable element, so people can put things up there, and it'll be shared across every one of the applications. Another new product we shipped just about 6 weeks ago for the Macintosh is our Mail 3.0 product. And this is a product we use a lot inside Microsoft. It was our first product we had to support the voice capabilities that exploit the fact that Apple's now putting microphones into most of their machines. We think that's a great move. It's a lot of fun to get mail with voice annotations in it. Maybe we're in the phase where people are overusing it. Like every great thing, color, graphics, people go wild at the beginning. But I sure get a lot of messages with voice inside them. One of the things we've done with this is make it connect up to all the other mail systems out there. A lot of corporations use props on IBM or DEC all-in-one, or God forbid they have PCs they want to connect to. And, so we have all these different gateways. We're also taking some of the concepts you're seeing up in the System 7 Finder, the extensive use of drag and drop, the way you can organize things, alias things, and bringing that down into the mail package so that the experience of organizing and dealing with your messages, finding messages, we're trying to make that as similar as possible to the same operations you do at the Finder level when you're dealing with files. And in fact, eventually when we get an object-oriented Finder built into Apple system software, that part of the mail package would disappear altogether. And what you'd see is heterogeneous objects being dealt with at the Finder level, not just files. And so a lot of the things that we spend a lot of effort doing in applications won't be necessary anymore. One of the interesting things we've done here is work with developers to get them to build in send capability right into their applications. So that instead of, if you want to send like a PageMaker document right there on their messages, a send mail command, you don't have to exit and do anything. You just trigger that command and it calls off to us. We've even made it so people can do that very easily from HyperCard. So we see a lot of offices where they customize up simple things for people who don't want to use the computer very extensively. And of course, custom format for sending mail messages is part of that. One of the things we've done with this mail package is make it more than just sending a simple message where you have to and from and then body text. We actually have a very flexible forms architecture underneath this. And so if a company wants to create a meeting form or an expense form or a donation to United Way form, whatever it is they like, they just create that. And actually the mail package propagates those form definitions around through the network so that anybody who gets a piece of mail can actually look at it, see it in that format. And we've been very surprised at how far people go in taking advantage of this, building in their own custom forms capability. Another interesting product we've had is called the Office. That's where we take everything all in one, either set of disks or on a compact disk where we put the documentation as well and sell it as a single product. Over time, I think this will become a higher percentage of our sales because the convenience of just having all your users be able to get at all the different applications is very exciting, and we're thinking about offering an even higher discount for people who want to get all these different capabilities. Also, by putting them all together, we're able to document what you can do with integration. And we've, particularly in the CD version, we've added a lot of interesting information that helps you work with the applications. Having 540 megabytes makes a big difference in terms of how you think about tutorials or clip art or data that can make that application an exciting application. And so far, a very small percentage of the Mac installed base has compact disks. But as I'll discuss later, we see that changing over time. And so a lot of our packages will come in a special CD version, not just the Office, but our other productivity tools as well. Well, the big opportunities that Apple's given us to exploit their hardware are ones that we've been very careful to aggressively take advantage of. We do use an approach called core development, where about 80% of a product is independent of the environment that it runs in. And so then we take that extra 20% and use that to, say, use Apple's Color or Apple Sound or tie into HyperCard, or most significantly, to tie into their latest version of system software. In the case of System 7, they gave us lots of advance notice. We've been working with it for a long time. It's all software. And so this year, all of our applications will be out with full exploitation. Well, what does exploitation mean? It means using a thing called inter-application communication. I saw a little article in your newsletter that talked about some of the things we were doing, and it suggested that the way we do our object linking actually is competitive with IAC. It's not at all. It's built on IAC. It uses IAC to communicate between the different applications. And so when an object understands that it's supposed to be edited, it uses its self-descriptive mechanism to know, how to find or fire off the application that understands that object, and that's all done through the Apple IAC. Likewise, we support all of the standardized Apple events. So far, Apple's only standardized a small set of events, and it's a tough problem. Over time, as you get all the important events standardized, things like how do you search across different types of data, how do you spell check across different types of data, then it's going to really allow for a homogenization of the applications. A professor from MIT, Mike Petruzos, came out and we were talking about some of the research that we've been collaborating on. And one of his initial comments is that the size of the manuals, Mac manuals on his bookshelf, is a lot longer than the size of the Encyclopedia Britannica. And so he was wondering why that is. Because fundamentally, what do you learn when you learn all these applications? You learn how to name things and select things and set some properties and search. And it's very basic operations, but you're learning them in a little bit different way across all these applications. So the kind of unification that the Mac has brought, the drop-down menus and file and edit, it's only a small distance towards the kind of sharing of concepts, sharing of learning that's possible once we get these standardized events. In fact, if the events were rich enough, you could use a common user interface and just be controlling the other applications without actually seeing their appearance up on the screen. That kind of fully object-oriented approach is probably 5 or 6 years away, but we're moving there one step at a time, and Apple events are a good start towards that. Apple's also built in what they used to call CL1. They now call it DAL, the Data Access Language. And Excel is the first application to ship with the ability to connect to that. In a sense, it's Apple's version of SQL. SQL is a universal way of reaching out to a network and getting it data. And unfortunately, there's some difference in dialects of SQL, but the differences are small enough that adapting an application to go out and read from all the popular SQL databases, very straightforward thing, and another thing that we've done with Excel. TrueType Fonts has actually been a collaborative effort between Microsoft and Apple, because that, of course, is shared between the system software that we do as well as Apple, and very easy to take advantage of in an application. You just have to make sure that you allow the different sizes that are available. And finally, Apple really likes this balloon help, so they've made it easy, and everybody does that. The most difficult thing as a developer is making sure you really do the Apple events right, coming up with creative ways of using the inter-application communication, and then doing full exploitation of what they call publish and subscribe. Now, one of the things we've done with inter-application communication is built objects on top of it, and we think that's some of the things we've done there really are a glimpse of where objects will be going. Well, during this decade, it's very straightforward. I don't think I have to convince people here that graphical computing will be dominant. I don't think even at the very low-cost part of the market, say $500 computers, that people will want to make the trade-off of having a machine that's purely character-based. And so, that C prompt or whatever it was will be a thing of the past. I think the idea of integration will become even more important. Where we're moving towards here is getting the data at the center of the interaction and getting rid of the application altogether. I mean, it'll still be there. There'll still be code that hopefully people will buy to put into their machines. But as far as what the user's thinking of, they'll think of moving it around in their data, that'll be very heterogeneous in nature. Of course, it'll be embedded in a document or embedded in a spreadsheet. But all the different types of data, whether it's table-like data, text data, formulas, voice, should all be possible to anchor in any of those containers. So inside a spreadsheet, you should have text. Inside a word processing document, you should have very rich tables. And by having that kind of mixing, you don't want to have these tough boundaries where when you go and find the different type of data, you, the user, have to think, this is spreadsheet data. Let me go fire up the spreadsheet. And in fact, you even want to move to a level where you can edit the data in place. You don't even get another window with all its menus and different commands. You say it's a drawing inside a spreadsheet, a very, very rich drawing. You want to be able to call the application code in a transparent way and be able to move and change the properties of elements of that drawing, no matter what drawing package you used. This is a great thing to get this integration approach, because it means that what's been happening with applications, where slowly but surely the word processor gets a little bit of the spreadsheet in it, and the spreadsheet gets a little bit of the word processor in it, but it's not exactly the same. That's making applications big, and it's making them more difficult to work with. By getting the integration down at the systems level, it's up to the user to think of these things as little tool pieces and think about how they want to combine these. In effect, this is just a use of a concept that was implemented in a very simple way in the original Unix operating system, and that was a technique they called pipes. If you wanted to do common operations, you would take nice little pipe utilities, connect them together in the right way. There were little piping utilities for sorting and searching and spell checking, all the different kinds of things that you might want to aggregate together. And so people who are good at using the Unix shell, which is not everyone, could do very powerful operations using simple applications. Well, this is the same concept where we're applying it to much richer data than just the character stream, which was the only data type that that piping approach worked with. Here we're applying it with all the clipboard data types and going beyond that, because each object is self-describing. And so no matter what operation it is, we just look at the object, and it can find out if that's a verb that it understands. Another big move is towards a new class of application development tools, so-called object-oriented development tools. We always talk about making it easier to write applications. And in fact, if you look at the way people write applications, it hasn't changed much in the last 20 or 30 years. By and large, people sit down to write C code, and that's it. There are a few elements of the application, for example, the visual appearance, where some of the better prototyping tools can save you the effort of building the menus and building the dialogue. But unfortunately, that's a very small part of most applications. Sure, if it's just a forms application where you're looking at database up on the data from the mainframe and you want to call it down or you want to enter data, then that user interface part, making that so you don't have to write a line of code, is very nice. But for anything that's more complex, you're sitting there writing very complicated code. Well, the first opportunity to improve on that in a significant way has come along with these object-oriented development tools. They're not going to be an overnight success, but with C++ and great object libraries, we will have a larger degree of code sharing than we've had in the past. It's the one great trick there is in program development, and that is the fact that if you use code that people have already written, then it saves you time. And essentially, object-oriented programming is just taking the idea of subroutines and going and making it more flexible. Today's subroutines get so tied up with the way data is represented that the closest analogy to trying to use somebody else's subroutine library would be trying to write a book and taking somebody else's book and using little fragments from their book. Certainly you could do it, but you'd end up changing every little detail by the time you were done, so you might as well start from the beginning. And so if we could get rid of those details, pull those out, then you might be able to share more, and that's exactly what the level of indirection that object-oriented programming provides. Today we're doing a little less than half of our development in C++. It is something to be careful of. When you break things up into objects, there's the opportunity to make things very, very inefficient. In fact, if you look at the Xerox Star, which was the commercial product that came out of the work at Palo Alto Research Center, was a very slow machine. And part of the reason for that was they used these advanced programming techniques to such a degree that their code paths were very, very long. When we talk about integration, there's some very straightforward scenarios that are interesting to think of. Let's take the idea of putting a voice annotation into a word processor. Now, one way to do this is to go to every application developer in the world and say to them, yes, you write special code that understands the voice object, and here's some user interface guidelines. Please make a little icon that looks like this, and please, when we click on it, bring up a little kind of recorder-looking thing like this. That's one way to do it. But unfortunately, that's a terrible way to do it. It'll take many, many years before it gets done. And by the time that gets done, there'll be some new voice format that will have come along, and then you have to go back out to everybody and tell them to do that again. So the best way to do it is simply tell people to have the ability to embed an object. And then once and for all, for arbitrary things, you support the idea of displaying it, which would be the little voice icon, the idea of double-clicking it, which means to play that voice, and you get to apply that across anything that you might want to stick inside the application. And that's what we've done using the inter-application communication facility. Well, this is, I think, a fairly revolutionary thing, not only for users in terms of being able to add things into their applications, but also for software companies. If you think of the structure of the software industry today, the big categories, spreadsheet, word processing, database, it's fairly tough for a small company, even with very good ideas, to get in and write applications like that. And so say they have an idea of how to do math formulas better, or tables better, or legal citations better. How would they pursue that idea? Well, they could write a standalone package that performs that function, but it's too difficult for users to use, and so they'll just continue to do it the crummy way in one of say, a popular word processor. With this architecture, an innovative software company can come along and actually give the user the benefit of that capability being built into the product. That is, it shows up right inside the document. If you want to change that data, you just double-click it, and a little window comes up and you make those changes. Now, embedding is where you take the description of the object and you actually include it in the document. Most of the time with voice annotation, you want to put it right inside the document so that when you move the document around on the network, it goes with it. If you want to share the object, then you use the file system, and actually instead of the entire object being there, it's just the name of the file, and that's called object linking. One of the difficult things about object linking is that, let's say then you take that file and you delete it, or you move it onto another machine, or you rename it, you have a fairly tough problem. Within a local machine, actually, Apple uses an ID scheme that allows you to track files as they move. But once you get out on the network, you have a problem there. And so advanced system software in the future will do a much better job at this idea of tracking references as they move around. Those of you who've used spreadsheets where you link lots of data together might have experienced this problem where if the data you're dependent on has different names or is in different places, it's fairly difficult to go back and update those references. Now, this kind of architecture of putting objects in documents or on spreadsheets gives you a lot more power than just data that's a black box. If the only messages that were there were display yourself, print yourself, and edit yourself, then it would just be an opaque object. And none of the operations in the application, this searching or spell checking, would operate on that. Fortunately, we're standardizing messages that include all of the common operations. And so you can really think of this as not just adding objects, but adding features to the word processor. And so you'll get lots and lots of packages, add-on packages, that are either ideas that the person who built the main package didn't think of, or they're things that only appeal to a specialized part of the market. Say scientists who want to do charts, who do very complex error analysis. Why not be able to completely substitute for the charting package inside Excel with another charting package. And in fact, this architecture gives us that capability. Some of the most advanced scenarios for using these integration capabilities get us to this idea of an agent. It's a word that's kind of overused, but the idea is something that can go out and find information that you're interested in and bring that down and alert you that some data is there. You could have that as an element, say, in your calendar program. You can have something that goes out, finds interesting events, and puts them there as tentatively something you might like to do. Well, this broad vision that we have of how the computer will change as a tool in the 90s, we've given it a phrase. We call it information at your fingertips. It's kind of hard to appreciate what we mean by that unless you appreciate it's something that we think it's going to take most of the 90s to achieve. The idea is that the way to measure a computer is to think of all the information that would be useful to you and bringing that together on the screen. And so if you want to browse the information, ask questions of it, dive in and see more detail, that it's very, very simple to do that. And of course, the computer is not anywhere near being that device today. In order to achieve this, it's going to require radical changes in the system software, how we think of networks, the efficiency of the networks. It's even going to require that we get a lot more information online and give ourselves ways of browsing that kind of information. Lots of information that's online today is very hard to use. Think of something like going out to find out the latest books that have come out. There's a service you can call up and do that query. Or if you want to go out and see the latest news articles on a topic, you can go out and do that. But people at Microsoft, if they want to do that, it's a little too hard to remember all the commands and interfaces because, of course, it's very different than working with your own productivity information. And so what they do is they send an electronic mail message to the librarian. The librarian is a human machine who understands how to use those services. That person goes out, gets the information, and sends it back across the mail system. So it works, but it doesn't work the right way because of the variety of user interfaces. And so to achieve what I'm talking about, we need to bring all that stuff together. It does involve some very advanced technology. There's not much invention required here. These technologies exist. For example, take the idea of security. When you have a network like this, you want the user just to log on once, to authenticate themselves one time. And as they're browsing around, there are dozens of computers that have the information that are important to answer that question. You don't want the user to have different passwords and be asked to log on to every one of those machines. Well, so how is this going to work? Well, what you want is your local machine to prove to those bigger machines who it is, and then they think, is this somebody they trust? Okay, they do. Once they authenticate who it is, then they say, well, okay, who's your user? They say who it is, and then that machine gives that user the privileges that should be granted to that user. This is a very tough thing because you should think, how can a machine prove who it is? If the machine proves who it is, how come somebody else can't watch it prove who it is, and then later that day they come along and they respond exactly the same ways, and so they're spooking the network and they can go in and get that information. Well, in fact, the field of cryptology is giving us a set of techniques that, based on complex mathematical theorems, you can actually prove who you are without giving away enough information that the other person can imitate you. And so it means that using these techniques that a company called RSA has patented, we'll be able to have very broad networks. Another great application of this technique is to eliminate the idea of viruses. When you have a piece of software, you think, has this software been changed in a bad way? Well, of course, people are very smart about viruses. They go and they put it in strange places, and maybe they know that you use a checksum approach to look at your program to make sure it's okay, or they know that you look at the date in the directory, and of course, all those things are things that they can patch up and change. But if the program has a cryptographic signature using these public key techniques, There's literally no way somebody can modify that program and have it appear to be untouched. And so as we apply these things, we'll eliminate the kind of problems that viruses introduce into the system. And in fact, things are going to get worse before they get better, because in an object-oriented system, you're executing a lot of different code. Imagine getting a mail message, and inside that mail message are lots of cute little objects. Well, when you click on those, it's going off and executing code to display that object or let you edit it. And so it means that lots of code that you don't think about running explicitly is coming onto your machine and executing. And so it creates incredible holes. Object-oriented systems create fantastic holes for viruses, and that's why we absolutely need to use these techniques. In networks, performance will not be a major issue. Optic fiber is getting very, very inexpensive, and so if we go out about 5 years, there'll only be 2 types of networking. There'll be the kind of networking where you can afford to string fiber between the 2 locations, and that will be a gigabit to start out with or a terabit later on. Or you'll have wireless communication, and there we won't get quite the same bandwidth. We'll get probably about the same kind of bandwidth we're getting today on local area networks. So say 10 megabit Ethernet-like speeds on a wireless basis. And so we'll still have 2 tiers, and we'll have to think about it. But really, it's 1,000 times more performance through that fiber than we're able to get in today's networks. And it changes the way you think about computing. It changes the way you think about storing data. Those data rates are so fast that if you sent that data to a Mac, it couldn't possibly absorb it all. I mean, it would. They actually have a technique they use where they loop it around in the optic fiber, and it just sits there waiting for the poor little computer to be able to absorb all that data. And it's it's like a shunting line, like you'd put trains off on, but it's running at the speed of light, waiting to get onto the computer. So it's a great advance, but like most advances, it requires the software people to change their mindset about how we're going to take advantage of the machine. Well, this is a controversial slide that I stuck in here. We can save this. We can save this for the Q&A. The question here is Windows bad or good? And there's certainly 2 sides to that. It means that Apple was right. Graphics interface is good. Really what it means is Xerox was right. I mean, I hate to say that. Means you get a little bit of coexistence, and it perhaps had something to do with Apple bringing their prices down. I'm not sure. One of the things I think that's great about it is this dynamic of having Apple need to take risk and do new things, take the much higher profits they receive by having a somewhat proprietary system, funnel those into R&D, and be willing to bring those out into new products and do risky things that certainly you'd never see IBM do. I think that's a great thing. And so they've spent a lot of money on R&D in the last 6 or 7 years, and certainly we have can expect some very interesting things. Well, other than Macs and DOS machines, the area of greatest interest, the only other operating systems that are expected to grow over the next decade would be the various operating systems that come under the name of Unix. This is a little bit oversimplified in terms of the... I couldn't get PowerPoint to put all the different things on here that I wanted to. It's not that Unix is a very good thing, and Unix is a fast growth operating system. And in fact, we were the first commercial licensee of AT&T, and Sun is the only other licensee that's actually licensed more copies than we have. We work closely with SCO. We license the product through to them. And we've done a lot of things with the product, but it is a different environment than either the Mac or, say, DOS and Windows. The difference is that with the Mac, nobody changes the system software. It's just up to Apple. They do it. In Microsoft's case, we license the system software to lots of people, but we don't let them change it. It says in the contract, you cannot change it. And so when a system runs DOS, it's well defined what that means. It may not be good, but it's the same everywhere. And so that's a statement of compatibility. What you have with Unix is it's just a starting point. And in fact, these various systems, many of them have not a single line of code in common between the two systems. If you take the two of perhaps greatest interest, you take the very far right, which is Steve Jobs' Next machine and all the different pieces that make up his system software, and you look at the piece of software that make up the Sun machines, you find that there's differences. And the way I'm illustrating this is I'm showing at the instruction set level, the kernel level, the graphics level, the user interface level, and then the style guide, the set of conventions that they promote in terms of people writing different applications. And so we have a lot of variety with these things. Now that's not necessarily bad. Allowing for some variety allows people to experiment around, come up with new things. It does mean that as somebody who writes packaged software, it's a very difficult case to make because I have to think of each one of these towers as an independent investment decision. I have to write my manuals. I have to do my testing, decide how to use the keyboard. I have to put it in a box, manufacture it, distribute it independently on each of these things. And the one of greatest popularity on here is the Sun, which sold about 170,000 units last year. Say the Next machine sold 11,000 units last year. And so the math of this is that last year there were 20 million of those DOS machines, 2 million Macs, a little less than 200,000 of the most popular workstation. And when it comes to software and deciding, is this going to be a good decision or not, it makes a big difference. Now, it's not clear whether these different types of Unix will come together. Actually, I didn't even list Apple's on here. I didn't put AUX, which would be a little different because actually, of course, it uses the Mac user interface and it has some of the Mac graphics capabilities built into it. But one of the big open questions is, will we continue to see this variety here, or will these varieties collapse? There's been some attempts like Open Software Foundation, Unix Software Labs to bring this together. But the reason that it's been very difficult is that even if computer manufacturers, let's take DEC, accept the fact that they can't write a completely proprietary operating system, the idea that they have to take an operating system and not mess around with it at all is very disappointing to them because they spend $1 billion a year on R&D, mostly software R&D. And so what does it mean for them if they just have to take an operating system and use it without any change at all? Well, that's the world of compatible computing. And so you see a clash between the effort of manufacturers to do semi-proprietary things where they use Unix as a base, and then the world where the operating systems comes from the software vendors like Microsoft, and the machines are literally compatible across manufacturers. And it'll be interesting to see how that plays out. We have a lot of things we do with Apple. We spend a lot of money on our lawyers, for one thing. We're up in the millions of dollars defending the idea that overlapping windows is not a proprietary technique. One of the exciting things about the current lawsuit is that the last 10 similarities we're down to, which are overlapping windows and icons, 7 similarities coming from overlapping windows and 3 from icons, every Windows system in the market today, every single one has exactly those 10 similarities between the Macintosh and Windows. And so unless we do a good job and convince the court that we're okay, then that's too bad for all the Windows systems that are out there. Today they'll all have to, I don't know, get rid of overlapping windows or something wild like that. Anyway, that's Apple's legal department. In terms of this TrueType font technology, I don't think it's been well understood exactly what we're trying to get to here. What we're trying to do is have document portability across the Mac and the PC in a fairly strong sense. That is you take the document from the Mac and put it on the PC, that the line breaks and page breaks don't change. It sounds like it'd be easy, but it's very hard to do that. Let's just take as an example a line that you have with a lot of different characters. When a word processor decides how to break that line, it sits there and it adds up the width of those characters, and it does the line break. And so if you use different fonts on the different computers, obviously the line breaks are going to be different. So you have to have the ability to have the same width and the same kind of fonts across those two different computers. And until TrueType, that certainly hasn't been the case for the built-in system fonts. It's even harder than I just described, though, because today what applications do is they take the width of the characters that are on the currently selected printer and use those to determine the line breaks. You see, on different printers, characters have different widths. If you have a 300 dot per inch printer, and let's say something is 10 dots wide, when you're on a 100 dot per inch printer, they have to decide whether to make that thing 3 dots wide or 4 dots wide. There's no equivalent to those 10 dots. And so it's either going to be thinner or wider. And so right now, even within the Macintosh, if you change printers, then your document can lay out. There is a technique of laying it out in a very device-independent fashion. And once TrueType is built into System 7, we'll start to see applications change in that way. So you'll get not only system independence, but also printer independence to move documents around. It's a case where something users, it's a very simple request for them to make. It requires an amazing amount of technology to make this work. We think TrueType's a great thing. It's fast, it's flexible. People can build fonts in it without paying royalties to anyone. Works super well on the screen. And our version of Windows that has this built into it will come out late this year. I want to say a few words about multimedia. Microsoft has been investing in this for over 6 years now. In fact, we have just over 100 people who are building tools and applications to try and pioneer this area. The term is used in different ways by different people. To us, it means delivering software that's not just a tool where you get a blank screen and then you fill in everything, but rather that the content, the information that comes with the software is what's interesting. Of course, the classic example of this is the encyclopedia, where you can take on a CD and put far more than the Britannica right there. There's other great examples. For example, we equip our sales force. Everyone has a CD player. And so instead of sending them paper every month about the new organization and the new customer prices and the new presentation on the software, we just send them a CD every month. They plug it in. It's got audio and video. It's basically a HyperCard stack that they browse through that contains the PowerPoint files and Excel files, or all the different things we want to get out to them. And so there's no paper filing system at all. This is very exciting to a wide range of people. Take government databases, census data, maps, filings, all that stuff the government can make available on a CD for people to work with. We're also working with Boeing to take their manuals for their planes, which are really one of the most expensive things about building a plane. The pages in the 747 documentation would not fit inside a 747. And the CDs to hold the equivalent, of course, would fit very easily onto one seat. Also, you could have when you browse that information, you could have it be specific to your particular model of 747. Now, building these content-rich applications with sound and animation, it's a very hard thing. The software is a small part of it. You can see that because take 540 megabytes. Microsoft is a huge software factory. We turn out, in the course of a year, maybe 30 megabytes of well-tested code. So if everything we did for a year was on a CD, it would only be about 6% of the capacity of the CD. So the other 94% would be some type of content that's created and valuable to the user. For us, what this meant is that we've had to go out to people who are experts in content. And in fact, we just bought part of a great reference book company based in the UK called Dorling Kindersley. This is the company that did a book called The Way Things Work, or the American Medical Encyclopedia, or the Eyewitness series. And so we have a partnership now where we're taking all their material, which is hundreds of reference books, and putting them onto CD form. And we think it's this type of title that can really motivate people to use computers on a widespread basis. In fact, we went into schools and asked people between the ages of 10 and 15 what they thought the greatest software program they can imagine will be. And we wondered, would they say desktop publishing or spreadsheet or word processing? They didn't say anything like that. They said, help me pick a college. Help me, show me what it's like to travel to the moon. Teach me how to draw. And all of those are examples where if you had a CD dedicated to that function, a little bit of code and a lot of content, of course you could do that and do that in a very compelling way. And you wouldn't require any manual of any kind. You just have right there on the CD the interactive tutorial using the sound and pictures to let the person do that. So we see software of a variety of types. Productivity applications, information applications, education and training, all of which will be new things that will make the personal computer a better tool. The final message I want to send and really reinforce is Microsoft's commitment to the Macintosh. We're going to be not only updating our major applications this year, we're going to be introducing a couple new applications in the next few months. We have more work going on in the Macintosh today than we ever had. We're very, very, very committed to it and full exploitation of everything that Apple does, as well as pioneering with Apple as they move into new areas, whether it's multimedia or handwriting or the advanced things they do in networking. Working with the Mac, and particularly working with users of the Mac, has been a great experience for us, and it's something we're very dedicated to. Thank you.
While I get booted up.
Okay. Okay. I'm going to do a real quick demo, but while we're booting that up, I'll take one or two questions. Go ahead.
Over the past several years, I've heard you talk about system-wide compatible architecture, but it's never open system-wide compatible architecture. That is, it sounds like something you and Apple are going to negotiate, and maybe if they threaten to sue you, Moreland and Ashton State will be on. But we're not talking about something the little guy has an entry into. It's obviously a lot.
Sure. All the approaches we're taking to allow the system to do this deep integration is all totally open stuff. What we call object linking and embedding, that specification is available to anybody who wants to call up and get it. We've sent it out to literally thousands of developers. In the next 90 days, we'll have a tentative spec for what we call OLE 2.0, object linking and embedding version 2. That's where we get the common control language to control applications. That's where we get spell checking, search, in situ editing in place. And actually, there's about 6 or 7 companies I know of, including mostly the larger companies, who are coming up with their own proposals for OLE 2.0. And then we're going to have an open forum, I think it's in 3 months' time, where everybody comes together and talks about that. But the whole point of this stuff is to make it available to all the software developers. Everything we've ever done from an API, applications interface point of view, has been totally open. And that's what we do in system software, the extensibility mechanisms we have built into our applications. With very few exceptions, the innovative work in software is being done by small companies. We like to think we're one of the exceptions, but having that open environment is really what allows things to move forward quickly.
So when will we see open architecture?
I don't know what you mean by open architecture. Our software is licensed to anybody who wants to license it. We are agnostic to hardware manufacturers. Nobody's ever been more open. We're the guys who give the customer a choice. They can pick one computer vendor on Monday, pick another one on Tuesday, pick another one on Wednesday, mix all those machines together, and there's no software lock-in of any kind. That's openness, flexibility to the max, and flexibility for the manufacturers to build the different types of machines they want. I don't know the specific software that you're talking about. certainly the network will be used as the primary means of distributing software in the future, so that we'll send out a CD to a university or a corporation. The administrator will stick it in there and put all that software up on a server machine. The notion of who then should be allowed to use it, well, that's to be. I'm sorry.
That's what C-server does.
It's a lending library kind of piece of software.
Yeah, I just wondered.
Fine. Okay, well, we'll do the demo and come back for some more questions. Well, this is Liz Welch, our product manager for Mac Excel. I mentioned earlier we've just sent the update letter out. Hopefully a few of you have got that in the mail, and I'll be sending it back. But let's see what we've got here. You can see now that there's a new thing that's been added up at the top here, and that's the toolbar. It's a set of icons that were designed to make it very easy to do common operations. And so, for example, if we select some cells, and we click on bold, then they're bold. Click on italic, they're italic. Left, centered, right, the common operations. One of the surprising things that we learned when we did our usability testing is that over 70% of all the formulas people create are just sums of numbers. And so it's easy for the computer to figure out what you probably want to sum. And so you see this little sum icon, you click on that, it proposes some formula, and then if you click it again, it actually enters that in. And so if you do a multiple selection of cells that you want to do a sum to, we'll just go up and double click now, and of course it goes in and enters every one of those numbers. You can see here we've got a problem with our column width, and in the past what you did is, of course it was direct manipulation, you went up and dragged it, but it was always hard to know if you wanted it to be nice and tight, where you should put it. Now all you do is double click, and then Excel goes down the entire column, figures out the widest element, and sizes it exactly that way. Okay, you might be able to see that a couple of the cells that we've got here have a little red dot. What that means is that if we double click on those cells, it'll go ahead and bring up the note that's behind the cell. So we've got that on a number of the cells, we can just double click them. Another thing we've done with double click is that if you don't have a note, what we do is we select all the cells that you're dependent on. And so you can see exactly what's affecting the different cells. We'll later see that in a cross-sheet scenario where it's even more powerful and very valuable. Okay. Now let's go ahead and talk about outlining. I said that this is a powerful technique that, although it first showed up in a standalone application and moved toward processing, you're going to see in all the different products. Internally, I was a real champion of getting this into the spreadsheet because I think it's actually more powerful in the spreadsheet context than anywhere else. The idea is that when you have a lot of these numbers, it's hard to move around and see what's important and then go see the detail and move back and forth. And an outline is perfect for that. So here, if we just take these rows we've selected and demote them, then we can see that it puts on the left there a little bit of outline, a minus. That means it's expanded. If we click on that, then it closes it back in. But an even more exciting thing we've done is we've given you a command that asks Excel to build the outline for you. And this is a sort of, some people would use the word artificial intelligence. It's a bad word to use. But what Excel's doing is it's looking at that sheet, and it's determining, based on the sums and the indentation, exactly what levels different things should be at. And so now that we've given that command, you can see on both the left and the top, we have a fairly complete outline. So we can just collapse it in and see just the bottom line, or collapse in and just see that one total. And then when we click on those pluses, it expands. Or, of course, up here we have this 1, 2, 3, 4 that lets us expand the entire outline to a particular level. And so we get a rich way of navigating between data. We've also taken this idea and used it to do an even more sophisticated form of consolidation than you've ever had before. What we're going to do is bring up, for this Blue Yonder aircraft, a couple of divisions, the Western Division and Eastern Division. Now, the way that other companies, let's say, have done consolidation is they introduce a concept of 3D, 3 dimensions. And what they do then is they take all the cells that are in a particular place, and they just consolidate using the position of the cells to pull things together. Well, that doesn't really work about 99% of the time, because the spreadsheets that you want to consolidate may not have the same exact structure. In this case here, we have one division. They make some common things, but one makes helicopters and the other doesn't. The other makes airplanes. And so if you did 3D consolidation there, you'd be adding the airplanes and the helicopters together, which is not exactly what you want. What Excel does when it consolidates is it actually looks at the labels and does the right thing on a corresponding basis. So this is our consolidate command. We could point at the information on the west sheet, add that to the list of things to be consolidated, go down, do the same thing on the east sheet, and then we'll say that we want to consolidate by the categories that are there. So as soon as we click OK, it's building up this consolidated sheet. And we can see that it took the union of all those different categories are all right there, done the right way. But we also see that it's used the outlining capability. Let's just click on one of those and see what it did. Well, what it did is it built a detail line for each of the sheets that we brought in. And in this consolidation command, you can use wildcard names, and you can consolidate from disk. The sheets don't have to be in memory. And so you can use this to consolidate hundreds of sheets. If we go look under airplanes, well, under helicopters there, you can see only the west division is making helicopters. So it did the right thing, seeing that that line was only in that west division. Yeah, we didn't line them up. I mean, you want us to line them up? Okay. Yeah, the rightmost digit. I mean, I don't know what's happening here. Maybe it's an optical illusion. Oh, that's interesting. I'm curious about that.
Welcome to BMUG.
I'm not sure. We'll look into that. We can double click on a cell here and show once again this idea of showing the precedence. So you see that when we double-clicked on that west line, it brought up the west sheet and showed us exactly that cell. Of course, if we go in now and change that, because it's linked, you can see it immediately comes into the consolidation sheet and everything is updated appropriately. No, when you double-click, it will go ahead and open up the document. Just like the consolidate command can work from the disk, it works extremely well. Yeah, another thing we have in here, we're going to skip past it to save time, but we have a goal-seeking capability. This was actually done by Frontline Systems. It's their what-if package, and we've done that by using dynamic linking, where we link right from the spreadsheet into their package. It's a very advanced solving type of capability. We're going to show this in this one? Okay, great. Another thing we've done to the spreadsheet is we've made it essentially a compound spreadsheet. Before with Excel, you could only have the text and numbers. Now you can draw, you can put text in there, all the different things that you'd expect to be able to do can be done right on the sheet. We've also made it easier to stylize your sheets. We have the style capability. So we can see this row 1 that uses a certain color and a certain font. If we just type a name in right here of heading or something, then whenever we want to go back and make another row look like that, we just use that heading style. Likewise, if we change the definition of heading, all those different rows would change in appearance. And so you get a lot more efficiency in how you're formatting your different sheets. You can see here on the toolbar some of the things we've got include the drawing tools, so you can just pick one of those, and you can see on this a little circle and arrow. We've used those drawing tools to put information right on top of the sheet. Also, if you ever want to put a piece of text in, you just click on a text box and then go ahead and draw that text box exactly where you want it, and you can type in multi-line text as a label on top of the sheet. This was our most requested feature. We actually did kind of an unusual thing. We ran a set of ads asking for suggestions for new features, and we got over 2,000 letters, of which about 90% we were able to accommodate with new features in this version of the product. Okay, now we're going to take and show how we can put a chart right here on the sheet. We'll select these numbers and then click on the chart icon here. And as soon as we just click and drag a rectangle onto the sheet, it puts the chart right there in that rectangle. Of course, if we want to edit that, we just click on that and select it as an object. We have a lot of new capabilities in terms of our what kind of charting we can do. Actually, before we show that, though, I want to show how we've tied the chart and sheet together. When you're doing budgeting or trying to put numbers together, sometimes, when you finally get to the chart, it doesn't look quite right, and then you want to change it. Well, if we want to take our cost data, we can just point to it with the mouse and then drag. It shows us exactly there on the axis what we're dragging to. As soon as we let go, we see that everything has changed. In that case, what we did is we dragged the cost variable, which was a constant, up and set it to a new number. But even better than that, let's say we want to change the profits. We don't like what result we've got. We can point to that. And as soon as we pick a new value for profits, it'll bring up a little goal seeker, and it'll ask us what other cell we should change in order to achieve this result. So here we're going to point to the revenue figure, click OK, and then you can see the solver working through the equation to try to figure out what kind of sales it takes to give us that level of profit. Another kind of neat thing we've done is we've got a new type of chart that we call picture chart. Anytime you have a chart up, if you select into the clipboard a little graphic object that we have here on the sheet, so we'll copy that into the clipboard, then we'll go back to the chart, and when we select that and paste, it'll actually change to use that as the icon. There's two different ways to do this. You can use a single icon and it'll stretch it to the bar, but if you like your apples stacked up, you can select that, and of course then you get more like Time Magazine does it. Now let's show we have a couple new chart types. There's not time to go through them all. Of course, we use the gallery to let you easily select these things, so you can see a lot of different samples of what we're doing with 3D capabilities. Let's just choose one of these, and then go ahead and of course, when we select that, it'll go ahead and redraw the chart. Another feature you have is that you can choose whatever view you want, and so in this dialog box, you see a little icon that's indicating exactly the perspective and elevation and rotation you're going to have. So what do we do next? I'm sorry? But just a clipboard. You just select it and... What's that? RenderMan rim file. I don't... You'd need a utility. Okay, as soon as we close the chart, of course, it goes back into the chart. Then if we want to format this object right there on the sheet in a kind of a fancy way, when we select it, we bring up our patterns dialog and then get the border we want. So that's it for the Excel 3 demo. Hopefully we've enticed you with that. Okay, great. the answer to that? Yeah, we have graphics filters like we've seen in PowerPoint that understand a variety of different graphics formats, and so you can open those and pull those in. I mean, you know, the standard method of data exchange within the Mac is primarily Mac meta files, and so you have various things that can convert to Mac meta files. But we also have specialized importers. We did our importers using we mostly wrote them for PowerPoint, where you want to have lots of different types of graphics. But the way we did it, our import filters work for all our products. So Word, Excel, PowerPoint all ship with a pretty rich set of filters, including things like the AutoCAD filters, CGM files, TIFF, EPS. EPS we actually do not display on the screen. We embed them and then we print them, but we don't have a displayer for EPS. There's been an extend filter written for Excel, and I forget who has that. What that is, it basically filters out the text elements. It lets somebody just see the plain text that's in there, and so you can use that for various search things. Like the On Location product, I know ships with an extend filter for Excel, so you can do the text searches into Excel files. But we don't actually ship an extend filter with the product. Now, you actually have to have a concept called design widths, not just device widths, and that's something TrueType happens to have. It's a very programmable font technology and very flexible. I think the key decision was made by Apple to use TrueType, and then we decided we wanted to be compatible with Apple. But in fact, it's a decision I support vigorously in terms of the flexibility that it provides. It's actually possible to convert ATM format fonts into TrueType form because it's a very descriptive language. It's not possible to take an arbitrary TrueType font and convert it back the other way. And TrueType transformations include the types of things you need to do in Arabic and a Hangul. You know, when you want to do ligatures and kerning and things like that, you can actually describe that in the font engine, the intelligent font engine. So we thought it was a better technology. Another element that probably did influence Apple was at the time ATM was a proprietary format. They hadn't published it. And it was only after Apple and Microsoft chose TrueType that Adobe chose to publish the so-called Type 1 format. I don't know. It's hard to choose. How do you choose? Up there? Yeah, the question is, why hasn't there been more progress making the Microsoft SQL Server available to Macintoshes? That's a good question. You know, there are a limited number. The only category where Mac still doesn't seem to have as many products as you'd expect is in the database area. There's a lot more database front ends running in the PC environment. And we have now 30 of them that are connected up to SQL Server. I believe that Omnis, I could be wrong about this, but I'm pretty sure that Mac Omnis is connected to SQL Server because I know their PC version is. I'm sorry? Okay. Other than that, I don't know what we've done with Fourth Dimension. I know we're working with Fox, but they don't currently have a connector. We are working with them to build one. Well, the patent system is a very dangerous system. It allows somebody to monopolize something for 17 years. And it's certainly a little scary that the patent office is giving out patents on things that I would have thought they wouldn't because they're so obvious to somebody skilled in the state of the art. We built up a portfolio of patents, quite a few, but purely on a defensive basis, so that if somebody comes along to us with their patent, we can say, hey, we got one too. Why don't we cross-license with each other? But once we get past this copyright problem, that's the next one the industry is going to face, and I think it could be very significant. I mean, there are patents like the idea of XORing a cursor to display a cursor. There's a company that claims to have a patent on that and has collected lots of fees. from us and lots of other people. You know, very, very straightforward ideas. There's this, who is this guy, Paul Heckel, who thinks that zoom racks, that you put a couple cards on a screen, it's like a breakthrough idea. You know, my mom's recipe cards work like that too. So the whole patent thing, it's interesting. I hope it doesn't freeze up software innovation. Well, certainly we take a fairly liberal view of what should be allowed and what shouldn't. You know, I think most reasonable people, when you get to the level of overlapping windows, would say, hey, that's an idea, and you know, you shouldn't be able to use copyright to control something like overlapping windows. When it gets down to a straight clone, let's go to the other end of the spectrum. Let's say somebody takes a product and absolutely does exactly the same thing. I have to say that I'm not an expert in law, I'm not stating a legal opinion, but I do think that probably should be protected. Your steering drive, the shift pattern thing is much more, you know, like the overlapping windows. And I feel sorry for the courts having to try and draw the line without any understanding of the technology. And, you know, I hope they do it in the right way. The question is, he said he's heard that the features for Excel on the Mac were created on the Windows version or vice versa. Oh, okay, what we used to do with our products is we did what we called leapfrog. We'd come out with the Mac version and it would be better, then we'd come out with the PC version, it would be better, then we'd come out with the Mac version, it would be better. For example, when we shipped, every Mac shipment we shipped was the best version of Excel we had. Now what we've done is we've come up with a new approach that allows us to align our shipment. And so what you're seeing here is we're shipping within about a 60 or 90 day period. We're shipping both the Mac and the PC version. The PC version has no features that are no general features that are not in the Mac version. The Mac version has all the basic Excel features plus the specific things we do to exploit the Macintosh. And it's that 80% shared code approach. OS2 is a form of DOS. I mean, think of our family of operating systems as all one thing. And I certainly wasn't trying to indicate which in our family would have which level of popularity. Today, DOS is overwhelmingly popular. A little over a third of the machines, PCs sold now, sell with Microsoft Windows, and OS2 has a very, very small percentage of the market. Over time, particularly as we get a thing called OS2 3.0 out, which is a pretty advanced piece of technology that will ship to developers this year, we expect that OS2 percentage to become significant. But that's up to us. It's just think of it as our high-end thing. I mean, Apple calls things System 5, System 6, System 7. We're a little crazier. We call one Windows and one OS2, and so there's different names. But it's just our high-end version. Okay, writing software for the Mac and for Windows is basically the same. I mean, you get down in C, you learn about event loops, you try to, you know, update the screen in an efficient fashion, but most importantly, you pick some application area where you have a novel idea about how to do things. It's a little surprising, you know, how how few software companies do sell in very, very high volume on the Macintosh. If you take Microsoft, Claris, Aldus, and a couple others out, I mean, you've got 75% of the market. So it's a challenge market, particularly Claris. Claris is very aggressive what they're doing with pricing and some of their things. So it's a good-sized market. The best data on all this stuff is the data from the Software Publishers Association. And what they showed is that in the fourth quarter of 1990, of the total market for personal computer software, the Mac was about 12%, Windows was about 12%, DOS without Windows was about 70%, and so everything else besides Mac, Windows, and DOS was just small. That was all of the Unix, OS/2, Amiga, Commodore, and those things were very small, and they'd actually shrunk while the other ones that I named had grown. Many of those had shrunk while most of the Mac had grown and Windows had grown. Today there are more Windows machines out there than Macs. We've sold enough copies of Windows 3, and actually for the first time the SPA data showed the Windows software market as being larger than the Mac software market. They're both very high growth markets. Apple has said that they shipped 85% more machines in the first quarter of 91 than they shipped in the first quarter of 1990. And we've certainly seen that in our software sales. Our sales are up very, very dramatically. So it's a very healthy market. As far as pen goes, we're big believers in pen-based computing. We think the idea of a notebook computer that you can just write on the surface of and have your handwriting recognized, we think that opens up the use of the computer in a lot of places that it hasn't been used today. I mean, take this user group. How many people have their Mac Portable sitting on their lap right now and are taking notes? I mean, I don't hear any, so not too many. But with this kind of notebook computer, it's something you take around and use. And there'll be a lot of machines coming out with that idea, either using our operating system called PEM Windows, which is a modification of Windows, or the Go operating system starting sometime next year. Well, the consumer electronics industry and PC industry will become one industry. I mean, the world is becoming digital, and the first digital consumer electronics product is the CD, and of course we adapted that as a peripheral in the computer world. The future HDTV standard, fortunately, will be digital, and so what will an HDTV be? It'll be a big frame buffer and a lot of compute power that knows how to decompress digital signals. And so as those two things come together, it's very important for computer companies to work with the consumer electronics companies, which means companies based in Japan, and make sure that these two things are complementary. I think Apple has recognized that, and certainly we've recognized that, and we're doing a lot of work with those companies in Japan. Well, we're talking with them about their technology. Well, I think I talked about how you'd use the RSA technology, in my speech. You know that the ISO standard for signature cards is being developed right now using RSA technology. The idea of how, in a secure environment, you go in and prove who you are is you basically have your RSA ID on a digital card that you carry around, and then you get authenticated. So a bank teller or somebody going into installation works that way. And future bank cards, they're looking at having the RSA type code on there. So there's a lot of people looking at applying this. The idea of using it in networks, DEC has talked about doing that. They're an RSA licensee, and so that, it's not a novel idea. A lot of people have come up with this idea. Even the idea of using it for virus detection is something that RSA itself has written articles about. Actually, I've done a lot of programming. In terms of writing a substantial amount of code that's in a shipping Microsoft product, that's some time ago. I've been in a few internal programming contests over the years, and still done reasonably well. But the last product that I wrote, the majority of myself, is a thing called the Model 100, and this is done back in 1982, ancient history. It's a portable computer, and we had to squeeze BASIC and an editor and some nice simple things into a 32K ROM. And so myself and Jay Suzuki wrote that ROM. Most of the stuff I wrote for Microsoft was written in machine code. The amount of C code that I've written that's in the shipping Microsoft products is very small. Yes, I certainly threaten to go back and do it from time to time. My contribution is at an algorithmic level, say how we do recalculation in Excel, say how we do line layout in Word, say how we're doing our query optimization and building the object-oriented file system. I still do contribute at the algorithmic level, but keeping the various groups coordinated. I spend 60% of my time on pure product issues. And what we have at Microsoft is we have 6 architects, people like Dave Cutler, who wrote DMS at DEC before he came to us, Charles Simoni, one of the founders of Xerox PARC, who wrote the Bravo word processor, a number of people. These are our top technical people, and those 6 cover all the different areas. And so I work with them to make sure they agree, they're coordinating what they do, and then I do lots and lots of project reviews. We have all the information online. I can look, sit at my machine and see how many bugs a product that we're working on has. I can see all the changes to the spec. I can see the latest schedule. I can look at the product support database, and I can see how many phone calls we're getting in on each product about what kind of problems for that product, and see what people are doing to address it. So we got a lot of information online that lets me stay involved, even though it's not code. It's up there. Well, multimedia computer is essentially a PC where you have the CD-ROM drive, perhaps even better audio than is built into the Mac today. Certainly the 8-bit pixel that you find in most of the new Apple models. That kind of machine, I would expect 5 years out to be a $995 computer, and perhaps the school's discounted down below that. That's certainly the kind of price we have to get to have this be pervasive. There's another form of a multimedia device, which we call a player, where you eliminate the floppy disk, perhaps even the keyboard. It's just the CD-ROM drive and the electronics, and you connect it up to a display. And so if all you want to do is browse the encyclopedia and look at the information, then you ought to be able to buy a player. And there's no reason a player should cost, well, more than, say, $300 in 5 years' time. Now, it wouldn't let you cut and paste that information and put it in your word processor. You'd have to get the full-blown $995 computer to be able to do something like that. But we do see that the prices continue to come down. And in fact, most of the titles that we're doing are educationally oriented. So it's our bet that there'll be lots of machines out there able to play the CDs that we're gonna produce. Well, CDI and CD-TV are very analogous to the player concept that I just described. CD-TV is a fairly low-cost player. I forget what it is, $995 today. They're out there evangelizing to get titles. CDI will probably come out at $995 in a year or so. These are not, our approach is to take and downsize the PCs so you can use the same software development tools and have a family where the player just fits into that. The approach of CD-TV is to do the same thing, but to use the Amiga as the big brother of the player. The approach of CDI is a from-scratch approach. They use a different operating system, CDR-TOS 68K, and so we have no plans to do titles for that at this time. It's been a long time coming. They've been talking about doing it for some time, but it's primarily backed by Philips, and it'll be interesting to see how they do with that. Yes, the question is about speech and what role that has to play. Speech will have an even more dramatic impact than even handwriting type computing. The reason we're doing handwriting is it's easier to recognize handwriting than it is to recognize speech. And we've actually done the work internally, and you can get great recognition. It's also, you have lots of feedback. You can see what's wrong, and the user is very intelligent. The user will actually, without thinking consciously about it, change their writing to be more recognizable. We've seen this. We've also seen that recognizing left-handers' handwriting is very hard. But since I'm left-handed, we've been working hard on that problem. Speech, there's two things to distinguish with speech. One is the idea of just taking the speech and putting it in the machine and playing it back. And I talked about how this OLE approach gives us the ability to put speech anywhere, and so you can annotate everything. And people now are letting you tie your PBX into your Mac so you can get your voice messages mixed with your mail messages. Very straightforward thing. The hard thing is then taking the speech and recognizing the words. The best work on this right now is done at CMU and MIT. I just spent Monday with Victor Chen, the guy at MIT, doing this, the best, I think, the best work in this area. By taking limited vocabularies, he's already able to do impressive things. His demonstration systems involve asking questions about walking around Cambridge, or he has another system where he's doing airline reservation. And he takes all the knowledge you can build up in this limited domain of what are typical sentences and what are sentences that parse well, and the speech information, and he does a very good job. Now, it's going to be, perhaps 10 years before we can do transcription. That is, taking an arbitrary set of words that might be in a word processing document and get a high enough reliability that it's better to do it that way than just teaching the person how to type. But within specialized domains, we should be able to have exciting systems in the next 3 or 4 years. Yeah, the idea of then hooking speech into the operating system is a very straightforward thing. The question is just, where is the code that actually recognizes the command? Our advanced user interface group has been playing around with the idea of, once we have speech, then how do you change the user interface? I mean, you probably don't have drop-down menus, and you don't say, OK, cancel, OK, cancel. And so we're prototyping up, assuming perfect recognition, what would be that user interface. And I'm sure Apple's doing the same thing. I feel confident that our work will intercept the ability to have this high level of recognition. But it's a bigger breakthrough than handwriting, and it certainly will come sometime in the next 10 years. Yes. There is a question of would that. Well, we don't have cubicles at Microsoft. Programmers get their own office, shut the door, get to have all the quiet they want. But yes, it is a problem to use speech as a form of input where you have all these people sort of interfering with each other. I mean, if that becomes a primary technique, I'm certain there's a lot that can be done with little headset microphones that are very directed in the way they get their input. I think that's a solvable problem. There are bigots who think that the keyboard's the only way, the mouse is the only way, the pen is the only way, speech is the only way. I mean, it's clear it's going to be multimodal, and the operating system is going to have to allow you to express a single command by pointing at the screen and saying, delete this, and then typing in what you want to replace it with. And so the real benefit comes where you accept all these different forms and you can mix them together. And different users have different preferences. For example, as we've done our multimedia encyclopedia, we have lots of things where it sits there and talks to you. Now we're fetching this article. And some people love it, the fact that it's telling you what's going on. And some people just can't stand the idea of the computer talking. And so there'll be different preferences that people indicate on the speech elements. Well, be more specific about what you mean about Unix's power. you're talking about RISC versus CISC? Okay, okay. I got you. Well, Microsoft's advanced operating system work is all entirely portable. And in fact, a couple weeks ago, as part of an announcement called ACE, we and 20 other companies announced support for a MIPS-based computer standard where you essentially take the PC as it's defined today, replace the Intel processor with a MIPS R4000 processor, which is one of the more advanced RISC processors, and then run this portable operating system. Our portable operating system will be able to run on any machine. We could even put it on Macs, but they already have an operating system bundled. You can put it on 88K, Spark, MIPS, and that's the future of operating systems. And Apple's been very clear that their future operating system work is being done in a portable fashion. Now, there are some tough transition issues of having multiple instruction sets. You go down to ACAD, look on those shelves, there's a lot of, in the Mac software section, there's a lot of 68K instructions in those boxes. And so it's unclear in a transition period, would you use emulation, which unfortunately is slow? Would you convince people to put them in the code in the same box? Would you have a separate section, which is the 88K software section? It's a little tricky, but I think Apple has indicated they'll be moving to support other architectures, and certainly we are with all the Windows applications. That's one approach. There's a lot of work that's gone on. You really don't want that. I mean, it takes a long time to compile up the software. There is discussion of what's called an application neutral distribution format, ANDF. And in fact, there's a guy at MIT again who's been doing, Stevie Ward, who's been doing some work on the idea of even not only taking programs, but also executing processes and moving them from one architecture to another. And there are some neat ideas here. Unfortunately, there's some efficiency overhead that in a world where there's going to be a small number of instruction sets, say 4 or 5 that are popular at most, I don't think, at least I can't see them paying off today, that those sort of independent techniques. It turns out you actually need to test your software for every instruction set. Even if it's C code, the idea that you have different byte ordering, or you have different floating point formats, or you can only access things on 32-bit boundaries on some machines versus others. They say these batteries are supposed to last 5 hours, but in this atmosphere, they only last apparently a couple hours. Way up there.
I wanted to ask the person who talked about multimedia and multimodal applications. When are your products going to be multilingual? For instance, when is Word going to be user manager compatible? Or when is Windows going to also support languages outside of ISO Lab 1?
Well, Microsoft Word is available for Hangul, Chinese, Japanese, Russian, Greek.
Sure, but it is good for those people who speak both Russian and Chinese, or for those people in countries outside of Russia where products, including the products in those languages.
No, it's available. It's a special order product if you want to get it. Here's the real challenge. The character sets that are used inside the Mac and inside our system software today, let's ignore double byte for a second. Let's just talk about single byte. You use 8-bit characters, which means you can only have 256 glyphs, letter forms, that you can uniquely identify. And if you take Eastern Europe, all of Europe, including the Danish symbols, Portuguese symbols, if you take the U.S., you take Arabic, you get literally thousands of symbols, especially with the desktop publishing symbols. And so what happens is in any one locale, you pick a code page, a specific set of 256, and then documents can only use those things, and they're not transportable. The way to avoid this is to have 16-bit characters, and there's an industry effort underway called Unicode, backed very strongly by Microsoft and Apple, to allow documents that can go anywhere in the world. Now, Unicode is controversial because the double byte characters, if you took all the double byte characters and you viewed Chinese and Japanese and Korean, CJK stuff, each glyph, each appearance as being separate, you'd get beyond 16 bits. You'd have more than 64K letter forms, and so you'd have to go to 24 bits or 32 bits. And Unicode does what's called Han unification, which is controversial. We think that Unicode will catch on, and we have committed that in the version of our system software we have in a couple of years, we will build Unicode into it. And what that does is it gives you document transportability throughout the world for all of the world's languages. But today we have specific versions worldwide. We get about 2/3 of our sales outside the United States.
Why then are your applications now compatible with Apple's script manager?
The reason we don't use the script manager is simple. It's not fast enough and it's not powerful enough. The concept of taking script management and putting it into the system software is a wonderful concept, but most of the features of Word would disappear if all Word was something that called the script manager. It's a very tough thing. Creating the universal text object that is fast enough so that everybody likes it and rich enough so that everybody likes it is one of those tough problems. And what you're probably going to have is a family of text objects, some that are for little, note-type things like text on an Excel spreadsheet, and then at the end of the family, something that's as rich as the layout code inside Word itself. Now, using object-oriented techniques, we should be able to view these as subclasses of each other, but the script manager is done on a full procedural basis, and so it actually is adequate for some non-word processing applications, but it's not. You wouldn't use it for a word processor or a desktop publishing package.
Except that other people have very good word processors and desktop publishing products out there that are script managers.
I'm not aware of that. I mean, I can go through the specific features you have to give up to use Script Manager, and we'll just benchmark these things versus each other. If everybody in the U.S. wants to slow down their word processing by 40% because you want to put Greek characters in, that's fine. But there should be a way to get the best of both worlds. Oh, that was 607. The way we're doing our applications is that they do not require System 7. When they detect System 7, for example, the publish and subscribe menu items didn't show up there. If it's running on System 7, publish and subscribe show up. And so we will continue to run on System 6 for a number of years, and we'll just watch how quickly people transition from System 6 to System 7. So we actually have to test it in all of the variety of System 6 environments, which is many, and on System 7 as well, the new features come up. But we're not allowed to demonstrate things publicly on System 7 at this stage. No, I have a car that is not usable inside the United States. It's actually... it's too fast in this case. It's a Porsche 959. It's in the free trade zone at Oakland, and someday I may be allowed to use it. It's the crash test that's the problem. There's few enough of these that you can't do the crash test. No, that's deep, dark history. Actually, what happened was when we were first working on the Mac, Steve, I said I wanted to write BASIC because it's one of the original things that we had done. And he said, no, don't write BASIC. We have a guy internally doing it. Well, about 6 months before the Macintosh shipped, Steve realized that their BASIC wasn't going to get done. And so I asked a guy who works for me, Tom Corbett, who came in and worked day and night. And actually, it was one of the applications shipping on the very day that the Macintosh shipped was our BASIC. There's a very, very small markup for BASIC on the Macintosh, but we had it out there. Then about 3 years later, so Apple had been playing around with their BASIC and never actually gotten it done and gone through some betas and various things like that. The license for Apple II BASIC expired, and we thought, well, this is a good thing. Maybe we should think about what kind of royalty we should charge for the Apple II BASIC. What we actually did is Steve was cutting things down because when the Lisa and Macintosh divisions merged, he had this he only wanted 100 people, and he sort of had an opinion of the other people coming to his group. Anyway, he wanted to cut down a lot of projects, and including that BASIC project. We did a deal which ended up being a very dumb deal for us, where we actually bought the code in the Apple Mac BASIC, incorporated some of that in our BASIC, and sold that in return for giving an indefinite extension to the Apple II license. And it was just a bad idea on my part, but that's what we did. And the question is, what magazines do I read? The Economist. I read all the standard stuff: Economist, Business Week, Fortune, Time, Scientific American, Science News, and then I'm sorry. I read that on the plane coming down tonight. Actually, no. I get a few of the SIG newsletters, but I don't read SIG 8. I don't read ASM. In the trade press area, there are so many. I read Mac Week, Mac World, and Mac User, PC Week, Computer World, PC Week. Did I say InfoWorld? Computer World. There's so much. Monday is a wasted day. You just read through all this stuff. The nice thing is that we have electronic mail, and we send around mail on things to make sure that everybody's seen the stuff they should see that are on in those periodicals. Sure, I have a subscription to that. When I need portable computing, I actually use an IBM compatible machine. On my desk, I have an FX with the radius tilt monitor and 486 machine. I have both sitting side by side. I tend to use my PC for email. I tend to use my Mac for word processing and spreadsheets. At home, I have a CX with a radius color monitor, and I have a CD so that I can play around with all the stuff that comes out on CD. And I also have a 386 machine, actually a compact at home as well. At work, I have both a HP LaserJet 3 and I have an Apple laser writer. But seriously. Yeah, I think you'll find in Excel V3 everything will recalc is certainly a lot faster, and we put a lot of effort into speed tuning it. There's such a wide variety of operations. You might find one or two that slow down, but I think in this case, on balance, you'll find it substantially faster. You might look at some of the reviews that show the different speeds, or when you get the copy, you always get the right to use. You can continue to use your old version. In fact, the way we do the install lets you go back to your old version whenever you want. I guess a few more. No, it's written in C. Well, Mac app's not an object-oriented language. Mac app is a set of object-oriented subroutines that you use normal procedural languages to call. We use our own subroutine library, so it's a piece of C code, a big piece of C code. Well, the Apple user interface guidelines haven't changed for a long, long time. And, you know, things like window drop-down or how we do previewing the fonts and the dialogues or, I'm sorry, pop-up menus. There's a lot of things that applications writers aren't getting any guidance at all. And I think it's pretty scary. When I look through Mac Week sometimes and I see these screenshots of new Mac applications, I think I'm reading a Next journal. I mean, people are doing very different stuff on the Mac. It's like the early days of the Mac when there was so much variety. The work that Apple did on user interface guidelines is great stuff. As far as it goes, it's great stuff, but it doesn't go far enough. And you know, we've encouraged them, come on, speak out, you know, about pop-ups, speak out about the font dialogues, color dialogues. I mean, there's some of the stuff that's very straightforward. Now that's just standard user interface stuff. When you have a user interface group that are exploring things, they're supposed to try every crazy thing in the world. And so they just have prototyping tools, and they're trying out a lot of stuff, some of which assume advanced hardware capabilities like motion video flat screen. You see, if the screen was just this nice little flat screen and your whole desktop was a screen and your whiteboard or chalkboard was a screen, and say instead of having to use a mouse, you just had something on your finger where you could kind of point, the way you would interact would be very different. And so we have different groups that assume different types of hardware advances and then play around with it. And then there's a group that tries to figure out, okay, if we're going to go to there, how do we get from here, where we are, to there? And it's a very tough problem because most of these techniques, just to give you an example of one of the dilemmas, what used to be that top-level menu where you have to go all the way to the top of the screen and click down on it, and then you see, oh, which commands are active right now, that's a bad idea. I mean, it's kind of a game. You select something, and then you kind of look and say, well, what's it allowing me to do? Well, it knows there's only two commands active. So it knows you're going to hunt around. But it knew that it only activated, which menus were activated. So it's not a optimal interface for the long term. There's a lot of new thinking that has to go into it. And yet we'd like to do it so that the discontinuity for the user isn't too wild as we move in that direction. And that's the type of thing that it'll be interesting to see how it gets solved. It's here. The reason I favor CDs as a way to get mass information out there is because the limited bandwidth of other forms of communication. The effective data rate of having a postman bring you a CD once a month is like having 80 lines, 80 modems into your house 24 hours a day the whole month. And so, that postman, he's a high bandwidth guy. And so I believe in hybrids. They'll bring you the yellow pages, and you'll sit there and browse them, and then when you want to call somebody, you just say call. Or the Sears catalog, you can have a picture of a house and then move around in the house and see something you want to buy. When you click on that, then maybe it's using the low bandwidth connection to see if there's a special on that or what's available today and displaying that for you. So I think hybrid forms are great. Someday there'll be fiber into your house, and then what do you need the CD for? Well, even there I can make a weak argument for it, but it's a read-only media. So if you go out 20 years, literally everything will be in digital form. Every still image you take, every moving image you take, everything you record, every piece of music you buy. And so you'll just have this vast database where you can select things and merge things and record things. And part of that will be through the high-speed pipe. Part of it will be local storage. I guess one last one. I actually wasn't aware that it's a membership-oriented organization. Well, Mitch and Steve, but I think Mitch in particular in this case has devoted a lot of his time to it. and has a lot of strong beliefs that freedom of the press issues, we need to think really hard how those apply in the digital world, or privacy issues, how those apply. And he's making a very positive contribution. I had a chance to talk to him at one of the industry conferences, and I'm supportive of the work he's doing. I wouldn't pretend to be an expert in it. I mean, one nice thing about him is he doesn't have to go in and do a full-time job, so he's been able to take some of his time and work on this thing. I'm just saying I'm naive about it. Mitch is gotten to understand the issues pretty well, and it's something I'm supportive of. If he had asked, Mitch has a couple other causes he's asking me to give money to, but maybe once I get done with those, he'll ask for the electronic frontier thing. I'm seeing him tomorrow. The Computer Bowl quiz contest is there, and Mitch was the best player of all time, and so we're having I was the best player last year by a very small amount, and so we're having a contest, which I'm sure he'll win by quite a bit. But I'm sorry? I don't know. I thought there were some broadcast centers where you could go and watch it. I don't know. Aren't there a couple different places you can go here in the Bay Area? Oh, it's actually broadcast. Well, great, great. Okay, well, I'm set. Thanks.
Thank you very, very much. Well, now that we've waited all this time, we have Raffle Mania here. Does everyone have tickets? Huh? Oh, great, because one can go to our San Francisco meeting, which would be very nice. Okay, does everyone have a raffle ticket? We have just so many, many things. It's unbelievable, all the number of things, including really, really great Studio D Digi-Design tapes. And we've got our gift certificates, we have T-shirts, we have software, including Microsoft Excel,